Welcome to this unit where I'm going to talk a bit about how we can use the formula that's available for us. In particular, here in this unit, I'm going to talk about the part on correlation, or in particular correlation coefficients. Well, before we get there, first part would actually be calculating the covariance. The covariance we can either write with COV of x and y, or with the small sigma. The small sigma, which we already know from variance or standard deviation. And well, that's not so different from what we're doing here. When we calculate the variance, we basically calculated the difference or the distance from each observation from the corresponding mean. So if we calculated the variance for x, this was actually for each observation, the observation itself, the xi, minus the average of x. The only difference, we then squared this. And here, instead of squaring this, we multiply the x part with the corresponding y part. So we have a pair of xi's and yi's, so that's our data points. And for each data point from the x value, we subtract the mean of x. From the y value, we subtract the mean of y. We're doing this for all observations. Now we take the average of all of them. Here you see it's with 1 divided by n. However, we could, if we wanted to, also go with a corrected version of the covariance, meaning we go with 1 divided by n minus 1. Okay, this could be a bit tedious, so an easier way to go about this is if we simply, for each observation, multiply x and y value. This will generate a new row in our table, in our data table. And then for this row, we just calculate the average. This would give us the average of x times y. And from this, we subtract the average of x times the average of y. And those two values usually are different. So here we might get something which is different from 0. This is actually the covariance. Could be positive, could be negative. This is also the first input part for the correlation coefficient after Brevet and Pearson. Because if we take a closer look here, this correlation coefficient, usually marked with a small r or with a rho, here is covariance, that's the sigma xy, divided by the standard deviation of x times the standard deviation of y. So here we have the same formula as before for the covariance. And then it's divided, that's here, the part, the variance of x. Square root of this gives us the standard deviation. And here the variance of y, square root, gives us the standard deviation of y. And as I said, variance is just the squared distance each of the observations has from the corresponding mean. Here we also have a way of simplifying this. So for the variance of x, we can use this formula where we square all the x values and then take the average thereof and subtract the squared averages. So this here is the variance, and then square root gives us the standard deviation. And well, if we can do this for x, we can do the same thing for y. So this is relatively easy, but the Spearman looks way harder with all the other stuff. However, once we got this is basically exactly the same with one small difference. With Spearman, we cannot calculate variances, covariance, and stuff like this because it's for ordinal data. So what we do instead is first we rank our data from smallest to largest. So we introduce a rank, and here the R of x simply means the rank that the value x has in the overall data set. R of y is the rank that this specific y has in the overall data set. And then, well, if we introduce two new rows where we have the ranked data, we can simply continue working as before. So using the Pearson correlation coefficient, the product moment coefficient, on the ranked data set. So this is simply the same formula as here, or rather as here, but with the ranked variables instead of the original raw variables. So we simply use this formula and replace x by the rank of x, y by the rank of y. And then do the same thing as before. The neat thing is, this will always work. However, in the situation where we do not have ties, so where each rank is assigned only once, we can simplify this even further. That's the formula down here. We simply have to take the difference in ranks from the corresponding x and y values and square this distance or difference, and then sum this up for all observations. So we don't even have to have specific average. We're doing this automatically down here. But in the end, square differences between x and y, sum this up, multiply this with 6, and it's always 6, and then divide this by n times n squared minus 1. When you got this whole part, just subtract this from 1. So here, this just means sum up all the stuff after it. This is just the corresponding rank of x, the corresponding rank of yi. So if you have like 10 observations, you have to calculate 10 squared differences, add all 10 up, multiply them with 6. Then you go 10 times 10 squared minus 1, so 10 times 99. And well, that's already all there is, because we basically only have those two formulas for correlation here. Well, this then already concludes the session. So if you look for additional parts on the formulary, feel free to visit the other corresponding courses here. Else, I say goodbye and see you next time.